Greetings everyone. In this voiceover I want to touch on the popular slang definition: true positive, false negative, and true negative, and where they're coming from. So imagine here we have an output of the neural network and of this model, and the idea of this model is that it want to detect the existence of a gun in the frame. So this short video consists of several frames, and we fit in the frame in the model, and the model outputs the label whether it detects the gun or not. So you can see, if you look at this video for a while, you see that there are frames when the gun is actually in the frame, but the model does not detect it. And there are also misleading detection, like it detects the whole frame. There's a flash of this example, and so we wanna get the accuracy of this model. And so the first step is to build the confusion matrix. So let's talk about the confusion matrix and where it's coming from actually. So here I have this table. Here I have this table over here, and the columns of the table, are their actual values of the frame. So the first column is the column when the frame contains a gun, and you have an example of this frame. Or there is a possibility that the value of the frame does not contain a gun, and here is the example of this particular situation here on the right. So again, the columns are the actual frames, and it's a binary situation, so we whether and the frame whether going to contain the gun or it does not or it won't contain the gun, right? So gun and no gun. Okay, and the rows will represent the prediction of the model. So the first row is yes, the model predicted there is a gun, and the second row is no, the model predicted that there is no gun. Okay, let's talk this through. So if there is a gun and the model predicted yes, we're happy. The model does exactly what it has to do. The model predicted yes, but there is no gun. We're sad because the model did something that we didn't want it to do. Okay, there is a gun and the model predicted no. Again, we're sad because there is a gun, but the model says there is no gun. We are unhappy. And finally, there is no gun and the model says no gun. So we're happy. All right, so that's a basic idea behind the confusion matrix. Now let's jump into talking about the actual slang. So let's say I'm telling you that it's a true positive. The output of the network true positive. What does it mean? Well, the second letter here stands for a class name. Class name. And currently, the way we call the classes, sort of yes or no, whether there is a gun or no. But in this framework, we call class as being positive, positive, or class name negative. In our particular case, well, when we have the positive, that's going to be that the gun exists. So class 1 or positive class or yes indicates that the gun is in the frame, and no is the negative class or class 2. And that's just a class name, and it indicates that there was no gun on the frame. So once again, the second letter is just a fancy name for the class. So in our cases, the class name was yes or no, but the standard way to know those are positive or negative classes. All right. So once we figure out that, so let's talk about another example, false negative. So negative is the name of the class. So it's class negative, or if you wish, class 2, right? This one was class 1. which is, again, contain the gun, or class 2 does not contain the gun, which is negative. Okay, so this is the second letter in this whole abbreviation. And we can, the second letter is the abbreviation, and the second letter is given by what the model predicted, right? So we can actually pre-fill the second letter right here in this confusion matrix. So here the model predicted class to be positive. On the second row, the model predicted the class to be negative, right? That's what the prediction is. The first letter indicates whether the model was correct in the prediction or not, whether the model was correct in the prediction or not. And if the model was correct, we say it's true. And when the model was incorrect, we say it's false. And so we already know whether the model was correct or not, because we filled in these happy faces and sad faces. And so in the top row left column, the model was correct, so we put true here. Then on the next one, it was incorrect, so we put false, and we continue in this manner to fill in the values. And that's all you have to know about how to build a confusion matrix. Once again, just to recall, there are two letters. So for example, true, negative. So the second letter indicates what the model predicted. So this is the prediction. And the first letter indicates whether the model was correct or not in this prediction. So when it's true, it was correct in the prediction. It did not make a mistake. And if it's false, it did make a mistake in predicting the label. In the next voiceover, we're going to talk about precision, recall, and F1. All those measures are the measures of the accuracy.